We'll be taking up the last part in unreal numbers, like determining the nature of decimal expansions of rational numbers. I'll just write this part down. We are talking about decimal expansion of rational numbers. How will you know from a decimal expansion if that is a rational number or not? Like it says, if any decimal expressions in the fraction format like 0.875 can be written as 875 by 1000. Now if this denominator 1000 can be expressed as a power 2 to the power m into 5 to the power n, in that case it is a rational number which is having a terminating decimal expansion. Now let us take up examples to prove this. Suppose another one. Now try this one. This 1000, is it possible to express 1000 in terms of 2 to the power m and 5 to the power n? See, 1000 divided by 5 gives you 200. 5 gives you 40. 5 gives you 8. 8 is equal to 2 to the power 3. So it is 5 to the power 3 and 2 to the power 3. So 0.875 can be expressed in terms of 2 to the power 3 and 5 to the power 3, thereby making 0.875 a rational number. Let us take up a couple of questions now. Suppose take this 29 upon 343. Now 29 upon 343, so we'll be trying to express 343 in terms of 2 to the power 2 to the power m and 5 to the power n. See, 343 is quite visibly not divisible by either 2 or 5. That means 343 cannot be expressed in this format, thereby making 29 upon 343 a non-terminating repeating decimal. Okay. Maybe one more. 13 upon 3125. Can we express 3125 in terms of 2 to the power m and 5 to the power n? Not necessarily that both have to be there. So it is 3125. I take a 5, so 6, 1, 2, 25, 5. So this is 25, 25. So 100, 25, then 5. 25 and then 5, 5. So it can be written as 13 by 2 to the power 0, that is 1 into 5 to the power 5. So that clearly makes it in the format of 2 to the power m and 5 to the power n. So it has terminating decimal expansion. Okay. Terminal decimal expansion, and the previous one I had taken up was non-terminating decimal expansion. Now look at this question. It says, I am just reading the question out and then write the numbers. It says 34.12345. Says, what can you say about the prime factorization of the denominator of the following rationals? Now this is visibly showing that it has a terminating decimal expansion. There is nothing being repeated, it says. So it is terminating decimal expansion. So its denominator has to be in the form of 2 to the power m and 5 to the power n, as because it is a terminating. Now if I've take up an example which writes 34.567 8 and there is a bar which shows 5, 6, 7, 8 is getting repeated. That means this is non-terminating repeating decimal. So that means it has denominator which it is the denominator which has more factors than 2 and 5. There can be more factors than 2 and 5 as because it is a non-terminating repeating ones. See, there is a basic concepts on real numbers are this many. We will now be taking up few past paper questions, or you can say the high order thinking skill questions. That's a hot questions. Okay, let me just put up a question first. Okay, it writes proof. I better write this using freehand. Root 3 is irrational. How do we prove root 3? In such questions, when you have to prove some root values to be irrational, you start with taking up just the contrary. As because you have to express that as irrational, let us assume the contrary, that root 3 is rational. You start with root 3 rational. That means what? Root 3 can be expressed in terms of a by b, where b is not equal to 0. I'll just write that way as well. B cannot be 0. Now if I cross multiply, we are assuming that a and b are co-prime. So it is root 3. I can write b root 3 is equal to a. Why I am doing so? Because we are assuming that a and b have one common factor other than 1. Okay, and we assume that a and b are thereby co-prime. So b root 3 is equal to a. Now if you square both the sides, root 3 is 3. This b square is equal to a. What does this mean now? A square, this is a square. This a square is divisible by 3. Thereby, because if I am multiplying something, like if I write 3 into 5 is 15. That means what? 15 is divisible by 3 when it is multiplied to 5. We are taking up this concept, and thereby we say that a square is divisible by 3. So a square is 3 into c. That any c, this c can be any integer. I'll just write c is an integer. So a square is equal to 3c. Now this I'll replace here in this equation. So what do we get? 3b square is equal to 3c square. That makes it 3b square is equal to 9c square, or b square is equal to 3c square. That means now b square is also divisible by 3. Now if you recall the theorem which says if b square is divisible by 3, then b is also divisible by 3. Remember the theorem? I think I discussed this in one of the previous sessions. If b square is divisible by 3, this is one of the application of this fundamental theorem of arithmetic. So b square is divisible by 3. That means b is also divisible by 3. So a and b have, if b, see, we here proved that a is divisible by 3, We here also proved that B is divisible by 3. See, A and B both are divisible by 3. That means that is contrary to the fact that what we assumed, that A and B are co-prime, so they don't have anything other than 1 as their common factor. But now we have proved that assumption wrong. We have now shown that A is divisible by 3, B is also divisible by 3. So this contradicts the assumption that root 3 is a rational number. Therefore, it proves that root 3 is irrational. Whatever I narrated, whatever I told you as an explanation, that can also be written to support your answer. I take up another question now. Okay, I write it here. LCM of two numbers is 45 times their HCF. If one of the numbers is 125 and sum of their HCF and LCM is 1150, find the other number. Now what does that say? LCM is equal to 45 times their HCF. It also says, okay, I'll just reuse the short forms. Maybe L is equal to 45H. One of the numbers is 125. It says that I'll use later. It also says sum of HCF plus LCM is 1150. So let us use these two first to find L or H. So I'm assuming now I replace L as 45H. So it becomes H plus 45H equals 1150. So that's giving me 46H is equal to 1150. So H is equal to 1150 by 46, that is 25. Now I replace this H here in L. So L is 45 into 25. Okay, I'll just let it be here as 45 and 25. Don't simplify it right now because we have to actually find the other number. One of the number is given to be 145. The formula says LCM of any number multiplied by its HCF is equal to product of the two numbers. I'm using some short forms. LCM we have now found to be 45 into 25. Let it be as it is. It will go for there's cancellations. HCF we have calculated to be 25. So product of the two numbers, the one number which is given to us is 125 and the other one, let us assume X. This is the one which we have to find. So X will be 45 into 25 into 25 by 125. So 25 into this is 5. So this also is 5. So now 45 into 5 is 225. So in this question, when one number was 125, the other one will be 225. Thank you.